Good morning to all. I think we are continuing this chemical admixture today. Till now, we have completed right from cement, cementitious material, aggregate, mineral admixture, and now it is chemical admixture. As you know, now any concrete we have prepared is we are using chemical admixtures because of the construction practice demand. But without chemical admixture, it is very difficult to make a concrete which can be handled very easily, place and finishing. To get that, we have to use construction chemicals in concrete. Now today we'll just see the concept and how they are working and what are their benefits in fresh concrete as well as in hardened concrete and how to handle this, because in market a lot of admixture, a lot of producers are available. As a civil engineer working at site, you must select appropriate material or appropriate admixture to be used in the concrete. Because huge number of admixture available and then you are confused what we have to look into that particular admixture as per our requirements. So we'll discuss on that also. And maybe today's whole lecture will go in that, or maybe we'll work partly next lecture also we can cover chemical admixture. So chemical admixture is a material which is other than water, aggregate and hydraulic cement, as well as additives like pozzolana slag, fiber, fly ash, those materials that we are using in the ingredient as in concrete or mortar. So this material you can add immediately during mixing or after mixing is over to modify the properties of concrete in plastic and hardened stage. That is the basic purpose of using these chemical admixtures. Now this effect is basically a temporary effect to handle the concrete. And with the time this effect is diminishing, maybe reducing, and then it is harden the concrete as regular concrete and develop the strength and other parameter with time. So chemical admixture typically we use in liquid form because it is very easy to dosing system and mixing. Since water is there, then we can add this. So mixing is very easy. Homogenization on the whole ingredients because quantum is very low in this. Quantum may be in the range of 0.5 to 1.2%, maximum 1.5%. With by weight of binder, including cement and pozzolanic material. So maybe in the range of maybe 2 liters to 8 liters or 10 liters maximum in whole 1 cubic meter of concrete. So we have water around 160 to 180 liters, and this is about 10% of that, or lesser than that. Maximum 10 liters, maybe 2 liters also some admixtures are working, depend on our requirements. So this is very relatively very small amount compared to other ingredients, and basic purpose has to be mixed with all the raw materials of concrete. Now some admixture also available in powder form. So whenever you are using a material, maybe ready mix mortars or ready mix plasters, in that also certain amount of admixtures are also available, which in dry form. So that also can be possible. So once you have come to the site, you can open the bag, get the batch and add the required amount of water you will get required about the workability of the product. So you get liquid form and also in dry form. But whenever you're using in concrete batching plant or any other purposes at the site mix, it is always advisable go for liquid form only because of mixing issues. So we have IS code for this, IS 9103. In that they are given a specification of that particular chemical admixtures. Chemical and air entering admixture including superplasticizers, solid or liquid or emulsion type to be added into the cement concrete at the time of mixing so that achieve desired properties in concrete in both plastic as well as hardened stage. So this one has to remember this is only to achieve desired properties in both the stage, even in concrete as fresh stage as well as in hardened stage. Now various types of admixtures available for the specific application. So depend upon your application, you can choose the what type of admixture we have to use in particular concrete. So accelerated admixtures are there, retarding admixtures, water reducing admixtures. Generally, we are working with water reducing admixtures. So whenever you have designed a concrete, you are not able to get a slump or workability, and there is a cap on water content and also cement content. So what we can do, we can reduce the water, add this admixture and achieve similar workability without increasing water content and cement content. So that is the major benefit about these products, water reducing admixtures. Then air entering admixtures also available where we can enter air into the concrete itself for the specific purpose. So once we discuss about fresh properties and hardened properties, why we need air into the concrete. Most of the tropical country we rarely use air entering agent, but cold weather countries they have to use air entering agent for the particular concrete applications. Then we have got superplasticizing admixture. One is water reducing agent admixture, second is superplasticizer. Those are basically having higher amount of capacity to reduce the water content. That's called about superplasticizers. Now, most of the admixtures are free from chlorides that we had discussed earlier also. Chlorides are bad for concrete reinforcement. So whenever there is a presence of chloride, you will find that corrosion will take place in the presence of chlorides. So manufacturer has to declare how much amount of chlorides are there. Actually, it should be very, very negligible levels. If you have more chlorides, it is bad for concrete. So one has to remember chloride-free admixtures. So when the site, we have got some admixture literature, you just go through that and see what is the level of chlorides present in the particular admixture. Now chloride, because these all admixtures, when a liquid admixtures, you can say there is a solid content maybe in the range of 25 to 40% or 45%. Balance is your water. Now your water, if you are not used properly, tested water, which is already specified what is the water to be used in concrete. In that chloride limits are specified. So whatever water we are using in this to make the admixture has to be meet the requirement given in the particular standard, especially for the chloride content. You cannot use any water, otherwise you will take sea water and make the admixture of that. That is not useful. for concrete. And chloride also, one of the advantage in chloride is you get setting acceleration, means you can get early setting. So that is very cheapest admixture available for accelerating the admixture, accelerator admixture. You can get early strength of that. So when you are using PCC, plain cement concrete, we can use chloride based admixture. But when you are using in RCC structure, it's not advisable to go for chloride. It should be chloride free admixture. Means all these, whatever types are there, A to E, all should be chloride free admixtures. So major reasons we are using admixture in concrete to reduce the cost of construction, because once you use concrete, very good workable concrete is very easy to place, very easy to compact, and get very good finish also. So your labor requirement is reduced, and you can have very speedy construction with this. We can use pump also and place this concrete. To achieve certain properties in concrete more effectively other than other means. Suppose you are working for a particular requirement of strength, and we are reached to maximum cement content specified in the code, and that particular only cement is available with you, we have to design a particular grade of concrete, and in the normal mix design you are reached up to the maximum level. Now how to come out that? I can use super plasticizer, reduce the water content, keeping same water cement ratio, and reduce cement also within specified limit. So those are the advantages, very broadly I am saying, but it has got a lot of other advantages also to use in the concrete. Now once you have very fluid mix or workable mix, mixing is very, very easy. Transportation easy, placing and curing in adverse weather conditions. So hot weather concreting or there is a cold weather concreting, we can take care of this using certain admixture and make concrete as per your requirement. Basic aim of this, you make your concrete as per your requirement and the application demands. Because in concrete, same grade you can use in piles, in situ pile, you can use in column, you can use in slab, but their workability requirements are different. Mix design grade is same. So you can play with this particular admixture in adjusting the dose of admixture as per the required workability requirement. So that is easy way to use this admixture very, very effectively. Now overcome certain emergencies during concrete operations. When there's a large pores continuum, maybe about 1000, 2000 cubic meter in one go you have to do. And we have to avoid the construction joints. If I have to avoid construction joint, if there is a breakdown in batching plant, there is a breakdown in the vehicle, or there is a breakdown in the site itself, some vibrator has failed, then you have to wait for 2 to 3 hours. So with that time, again your concrete is set, and then you can put there fresh concrete. There is a possibility you have as a construction joint or cold joint. Now that can be avoided if you use only retarders. So I can retard my setting time, maybe now 2 hours or 3 hours, I can go up to 6 hours or 8 hours. And then I can avoid those construction joint using certain type of admixture. Certain application you need to use early deshattering. Suppose I have to deshattering only for 2 days or within 3 days. You must have heard about PT slabs, retention cable slabs, where their requirement is at 3 days. So within 3 days, you are able to achieve 80% strength of characteristic strength. We can de-shatter or we can release these stresses. So in that case, you use such an admixture that you design also modify using certain admixture to achieve early strength. So that is possible using such admixtures. Now, one thing one has to remember always as a civil engineer, admixture is not substitute for your good concrete practices. As a civil engineer, as an executing agency, you must always remember, though it has got huge advantages, but that is no substitute for good concrete practice. You have to adhere to that practices only, and then keeping in mind you take the advantage of this material to get better benefit in the concrete, both fresh and hardened stage, to get better performance. Now in fresh concrete, admixture are also to increase the workability without adding water, because this is the whole concrete ingredients. You will find water is the cheapest ingredient in this. So any slump loss or any low slump due to the various other reasons, the operator or the man who is operating the mixer is first in his mind as without ready you add water to get more slump. Now once you add the water in the concrete and deviate from the designed water cement ratio, your strength will go down, your permeability will go up. So whenever there is a such incidence, you have to use admixture. So without adding any admixture, you will get more flowable concrete. That is the uniqueness of this particular agent or admixture. Without adding more water, you will get more flowable concrete. That can be utilized very, very effectively in the concrete. Reduce the mixing water, as I said, and reduce the water binder ratio also, cementitious system, which will enhance the strength. And once you reduce the water, your permeability also will low. As we have discussed, water requirement for the hydration is very rough, about 0.25. Working at 0.25 is difficult. So we are adding more water for workable concrete. And that added more water is also remain in the pores in the concrete and reduce the permeability, reduce the porosity, increase the porosity, and reduce the compressive strength also. To take care of that, I can add admixture. I'll get desired flow, workability, very easy to compact, very easy to pump and finish. So that is the major advantage of using admixture, but appropriate admixture. We'll discuss that. What are the things to be done? Accelerated setting time. Wherever I need early stage, early strength, like pothole repairs are there. So within 4 hours or 6 hours, we have to open the traffic. Or on the factory floor, within say 24 hours, you have to start factory again. So I can use such an admixture that my strength can be achieved as a desired period. So that period may be 2 hours, 10 hours, 12 hours, or 24 hours. But generally, our all calculations we are considering 7 days. If the 7 days things are okay, we go ahead with the construction. Retard the setting time. Setting time of concrete can be retarded. right form may be now normal concrete. If you take is initial setting time is in around 3 to 4 hours or 3 to 5 hours. Now don't confuse with setting time of cement and setting time of concrete. Totally different phases. Always people, any engineer, if you ask, what is the initial setting time of concrete? He always says 30 minutes. Now the setting time of cement is different. Setting time of concrete is totally different. So one has to understand this phenomena. When we'll talk about phase properties of concrete, we'll discuss in detail about the setting time of concrete. So this setting time can be retarded, maybe 6 hours, 8 hours. Now today, fourth generation or fifth generation admixture is available. We can keep concrete alive. Alive in the sense we can work on it. Means once you start pouring, and we can work on it even after 72 hours in 3 days. You can keep concrete alive for 3 days, and then it will start setting later on. Suppose I have to transport concrete from here to Pune, the 150 kilometers, 4 to 5 hours only in the traffic, and then placing. So emergency another 4 hours, so 8 to 10 hours. Whether it is possible? Yes, technically it is possible. You can travel the concrete, and concrete after adding water, where the reaction starts, that reaction can be stopped for certain period as per desired period, and add some accelerator to start the reaction. So that is also possible today. Concrete can go to sleep and they can make awake of it. So retarding setting time is very, very useful in today's construction practice. Why it is useful? Because most of the concrete we buy from ready-mix concrete plants. They are located X location, travel maybe 15-20 kilometers. Distance is not the issue. Due to the traffic, they may take some 1 hour, sometimes may take 3 hours or 4 hours within Mumbai also. So for large pour, to reduce the construction joint, I can delay my setting to 10 hours or 6 hours, looking at the traffic. Now if you go to the South Bombay, night heavy traffic is not available, allowed in night times. Now there is a huge raft of high-rise buildings. Suppose it is about 2,000, 3,000 cubic meter, and it has to cast in one go. So you can work in daytime, maybe 8 to 10 hours, and that layer can be remain concrete as it is for 20 to 36 hours, not set. And next day morning, again you can start the concrete. That way you can finish the concrete without having any construction joint. But for that, you need to do a lot of laboratory trials to fix up the dosage of that particular admixture for the particular type of cement. It's very, very essential. But it's possible. Today we are working like this. Concrete can be delayed for 8 to 10 hours without having any cold joint. We can proceed for the entire pour, maybe for 3 to 4 days or 5 days concrete. So that is possible. Reduce the bleeding. As you must have seen most of the bleeding. When you talk about fresh properties, we'll discuss in detail what is the bleeding. Bleeding is basically once you place the concrete and make vibrated and then make the finish, especially for the slabs where the large surface area is there, you'll find within say half an hour to 1 hour, thin water is coming up on the surface. That is called bleeding. So on the surface, what is happening is the water binder ratio, because of that bleeding, is very, very high compared to bottom concrete. Because bottom concrete with the capillary action, it has come out. and say, because in whole ingredient in the concrete, if you see, water is a lighter material, segregative 1, cement is 3, aggregate is 2.8. So this is the lighter one, it will come to the surface if it is excess in quantity. So that is also we have to, when you are designing, you will to take about the bleeding. So that bleed water you can assess in when you are designing in concrete. In mixed design stage also, there is a test given in IS code how to find out bleeding in concrete. Your 9103 also specifies this test. For this, when you are using this admixture, the admixture also sometimes entrain some water, air, and gives bleeding at the surface. So that has to be considered, and accordingly we have to design a concrete. Otherwise, we will get dusting. Dusting in the sense, you see these BMC roads, within 6 to 8 months, top slurry goes out because of the wearing of tires, with the contact with the tires, because that is very soft in nature, because it has got bleeding, huge bleeding on that. So you can see the aggregate itself on the surface. Should not wear maybe within 5 to 8 years, but it is within year it goes, because it's not taken care for bleeding. One of the reasons. Secondly, control the cement hydration. As I said, we can keep concrete alive for 72 hours. I can control my hydration process. I can control as per my wish. Whether I want 24 hours strength, whether I want 24 hours strength or 10 hours strength, or I want 3 days strength. That hydration control I can do using certain admixtures. It's very, very easy. Compensate for slump loss. Now, two things are happening here. Some admixture, if you add, you get initial good flow, but with time, you'll find there is a sudden drop in the slump or on the flow. So that can be controlled or compensate using certain admixtures. So we always call nowadays, because initially what is happening earlier, you prepare concrete and use within half an hour, because you are preparing at site itself. But now you are getting from ready-mix concrete plant, so it has to travel maybe 1 hour, half an hour, 45 minutes, or 2 hours. So whatever initial workability is there, it has to maintain at least minimum placeable concrete at once it is reached at site. But if you are not using appropriate material admixtures, you will find that slump has dropped drastically. You are not able to pump it. You are not able to handle it. So that can be compensated with the proper selection of admixture. Improves pumpability. We will discuss placing that will what is the pumpability, how to see the which is the pumpable concrete, which is non-pumpable concrete, how to design it. That we'll discuss later. But it improves. The behavior of concrete under pressure is totally different than normal placing concrete. Reduce the segregation, you get very cohesive mix. A certain admixture, if you add, you get very cohesive mix. Segregation in the sense that it will aggregate going away from the cement paste. So cement paste is one side, aggregate on other side. So that is not a good homogeneous concrete. So that can be taken care if you have an appropriate admixture. Then improves finishability. You get very good finish if you use proper admixture.